Hi there, this is Micki, and go ahead and introduce yourself.
My name is Itatiana.
Itatiana, and she chose the book Apple Fractions. So cute. Okay, so Apple Fractions, this book is by Jerry Pallotta. Pallotta, I think, is that how we would read it? And who illustrates it? Can you read that name? Can you see it?
Illustrated by Rob
Bolster. Yeah, or bolster maybe. I don't know. Hard to say. Sometimes that's why I always have to have people say their names for me so many times, because otherwise I will say it wrong and then I will say it wrong again and again and again. So I like it when people tell me how to say their name. Okay, this book is about apples and math. Apples are fruit that we eat. Do you like apples? What's your favorite kind of apple?
Green apples.
Yeah, like Granny Smith. They're sour, tart. They do not grow under rocks. They do not swim in the ocean. They are not made in a factory. Apples grow on what?
Trees.
Trees. And there's apple and trees. Can you count up all those apples? How many apples are there?
13.
13. Okay, apples. Thousands of different types of apples are grown around the world. Apples can be red. What other colors can they be?
Green. Dark red. Red and a little bit of yellow.
Yeah, yellow. They can be like a combination of all these different colors. There's beautiful pictures of apples. Do you like to draw? Oh yeah, you love art, so you can appreciate this. Someone, isn't that amazing? This person, Rob, Bolster maybe, he drew all of those apples. Could you draw apples like that?
Maybe.
Gorgeous, maybe. Fractions, what are fractions? What do you know about fractions already? They're weird numbers, aren't they? Fractions are part of a whole. So they're not the whole thing. They're if we break things up. A fraction is shown by placing one number over another number. A line separates the numbers. So there's all kinds of fractions. Can you see what kind of fractions are you noticing there? Do you see? I see the big one in the middle is 1/2, right? You have 1/2. We call this one 1/3, 1/6,
1/7. 1/9.
1/9.
1/10.
Yes.
1/5.
Yes. What about this one? That one looks different.
3/4.
3/4. Or you can also call it 3/4. This one would be 2/3. And then you have this cute little elf hanging out with 7/8. Macintosh. Ooh, that's a delicious kind of apple. Here is one whole Macintosh apple. This type of apple can be both drank or in a drink or as a snack. The Macintosh is very juicy, but it's also crunchy and fun to eat. So you have one whole apple. If you would like to share one apple with someone, what would you have to do?
Cut it.
Exactly. So 2 kids, 1 apple. A solution would be to divide the apple into 2 parts, just like you said. A stem for one kid and the apple for the other kid. What? One kid gets a stem, the other kid gets the apple. Is that fair?
No.
No, that's not fair. So you're right. We have 1/2. So we took the 1 and we divided it. We took the 1 apple, we divided it into 2 pieces. How about a better way? Divide the apple into 2 equal parts. Here is 1/2 of the apple. And the little elves are cutting it up. Here's the other half. So if I have 2 halves, how much of the apple do I have? I got both halves.
1/2.
I would have the whole thing, right? If I had 1/2 and then I had another half, I would have 2 halves. I would get the whole apple to myself. Here is the other half of the apple. 2 kids, 1 apple, 2 halves. Sharing apples and learning fractions is fun. Here is a golden delicious apple. So, can you see this book okay, the way I'm holding it? This apple is called Golden Delicious. On the outside, it has thin skin. On the inside, the fruit is soft. So here, they're cutting it into 3 parts. So we call this thirds. We have 1, 2, 3 thirds. That's the whole apple. What if 3 friends want to eat an apple? 3 friends, 1 apple, 3 equal parts. It's kind of hard to cut things into 3 parts, though, isn't it? Like if you took a knife, you would have to insert it here. You couldn't cut it in half as well. Cut it into 3 parts. So here's 1/3 of the apple, the Golden Delicious apple. Not all apples have a white fruit. The inside of this apple is light yellow. 2/3. Here is what's left from the whole apple. After taking away 1/3, you're left with 2/3. 1/3 plus 2/3 is 3/3, which is the whole apple. Yes. And here's your favorite kind.
Granny Smith.
Yes, Granny Smith is the green apple. This is a Granny Smith apple. Is it ripe? Yes. A Granny Smith apple is green when it is ripe. It's ready to be picked off the tree. The apple is sometimes hard to chew, and it is not sweet. It is a little bit sour. So now if we cut the apple into 4 pieces, first of all, we start with 1 whole apple. But if 4 people in the family want to eat 1 Granny Smith apple, the apple would need to be divided into 4 slices. You see that little elves cutting it up? So do you know another word for 1/4? Think about money for a minute. If you had 4 equal things.
Quarter?
Yes, that added to $1, we call them a quarter. So another word for 1/4 is 1/4.
Quarter?
Every family member would get 1/4. The top of the fraction is called do you know the top of the fraction's name? Starts with an N.
Numerator?
Yes, numerator. The numerator of the fraction is 1 because you have 1 of those pieces. So we have here 3/4 because I have 1, 2, 3, and they're all size 1/4. The bottom part of the fraction is called do you know that word? Here, I'll put it on the screen. You see it? The denominator. And denominator, it kind of sounds a little bit like denomination, like money. It's basically the size of the piece. So the denominator is here 4. Where did we get the number 4 for the denominator? Because how many pieces?
4 people?
Yes, there are 4 people, and so we cut the apple into how many pieces? 4 pieces, right? So the fraction 3/4 has a numerator of 3 and a denominator of 4. Yes. Here is a Red Delicious apple. So a Red Delicious apple is what most people think is their favorite apple. I actually don't like the Red Delicious that much. Many people think the Red Delicious apple is the best looking and the best tasting. I don't agree either. It is time to learn the parts of an apple. Do you know what the parts are called?
Yeah.
What are they called? You got a stem.
Skin.
Skin.
Pupil.
Or what is it?
Core.
Oh, yeah, it says pulp, yes, core, and
Seeds.
yes, seeds. And then this is an orange. We know what an orange is, but it's not an apple because it's an orange. It's another kind of fruit you can enjoy while learning fractions. There is no need to cut it because under the peel, it grows in wedges. Oranges grow in warm climates and apples grow in cold climates.
Cold climate.
In fact, Washington, that's to the north of us, they're very famous for apples. Did you know that? Washington apples. Yeah, a lot of apples grow in Washington, probably even in Oregon too. I have some apple trees in my yard. Now we have the Gala apple. So we're going to cut it. Uh-huh.
I like those apples.
You do? Yes, I do too. Because they're kind of a little bit sweet, but also a little bit sour too, right? Gala is a medium-sized apple. It's about the size of your fist. The largest apple are as big as grapefruits. The smallest are the size of a cherry. This Gala is cut into 5 equal parts. Each piece is, if it cuts into 5 parts, how much is each piece worth?
1/5.
1/5, exactly. So 1/5 plus 4/5 is equal to 5/5. When the number above the line and the number below the line are the same, we call it 1 whole. So if you have 5/5, you automatically have 1 whole. Here they wrote 1/5 plus 4/5 is equal to 5/5. Notice, what did we do when we added these fractions together? What did you think you would have to do? You see that addition problem? How did they get that? So here we have 1 plus 4 gives us 5, but we don't add the denominators. Do you notice that the 5, 5, and 5, that all stays the same? And that's because the denominator tells us how big are each piece. Notice as the fraction, the denominator gets bigger, what's happening to the sizes of these pieces of apples? Would you rather have 1/2 of an apple or 1/5 of an apple?
1/2.
1/2 would be more apple, wouldn't it? So as the denominator is getting bigger, the size of the piece of apple is getting smaller. Do you know why that is? The number in the denominator gets bigger, the size of the piece of apple gets smaller. Why is that? What is the denominator 5 telling us about the apple?
4 pieces?
Yeah, so if the denominator is 5, we're going to cut the apple 5 times, right? Cut it into 5 pieces. So if we cut the apple into 6 pieces, then we would get the fraction 1/6. This says apple trees grow flowers in the spring. Have you been seeing all the spring
Cherry
flowers coming
blossoms?
up? Yes, cherry blossoms and apple blossoms. Bees fly from flower to flower. Why do they do that anyway? Why do the bees fly from flower to flower? What are they doing? Do you know?
No.
They're pollinating them. So when a bee lands in a flower, you see that little bee in the flower? It's picking up the pollen from that one flower and it's spreading it to all the other flowers so that the apples can grow. This is the start of an apple. Thank you, bees. Without bees, there would be no
apples.
Can you imagine a world with no apples? What else do you think we wouldn't have if we didn't have bees?
Flowers.
Yeah, well, we might have flowers, but maybe not. Who knows? We don't even know, right?
Honey.
Honey. Oh, we wouldn't have honey, that's for sure. 1/6 of the bee is busy working. 5/6 of the bees are looking for another apple tree, or maybe even a pear tree, a plum tree, or even a cherry tree. So they're looking for all of these flowers. The bees need the flowers, and then you see how they pick up the pollen on their legs. So funny. Okay, here is a Cortland apple. If you cut the apple sideways, you will notice that the core is shaped like a star. Dividing the apple sideways instead of from top to bottom, will not give you equal parts. The top and the middle and the bottom of the apple are each different widths. And here we divided the apple into, if it's 6 out of 7, how many pieces did we divide the apple into?
7.
7 equal pieces. The denominator tells us how many pieces, and then the numerator 6. If you get 6 out of 7, 1, 2, 3, 4, 5, 6, do you get most of the apple, or who gets a better share? 1/6? Would you rather have 1/7 of the apple or 6/7 of the apple?
6/7 of the apple.
Oh, and 6/7 is going to be more than 1/7, and you can tell that they're going to be the same size because the denominator 7, and you're going to have more pieces if you have a bigger numerator, right?
Mm-hmm.
So important to understand fractions. Asian pears. Sometimes a look can fool you. This fruit looks like an apple, and it's shaped like an apple, but it tastes just like a pear. Do you like pears? How do pears compare to apples to you? What do you think the difference is in their taste and their texture?
Green.
Yeah, sometimes
green. Sometimes they're shaped
right.
a little
Mm-hmm.
something different.
Right, and this Asian pear actually looks like an apple. I find pears sometimes to be a little more mealy, right? They're like a little more gritty. So this is a pear. Let's use this Asian pear to learn about improper fractions. You know what an improper fraction is? No? Have you ever heard of that before, improper fraction? Yeah, so an improper fraction, this is a pear divided into 8 equal pieces. Each piece is 1/8 of a pear. A whole pear would be 8/8, right? Because you would have 8 pieces, that's the numerator, and they were all size 1/8, that's the denominator. So if you have 8/8, you have the whole pear. Imagine that you had 9/8.
Whoa.
If you had 9/8, that's what we call an improper fraction. You would have to use 2 pairs to make 9/8. 9/8 is really 1 whole pair and 1/8 of the second pair. So if you had this whole pair, 8/8, and then you had another slice that's 1/8, you would have 9/8. You would have over 1 pair. So when we say that the numerator is bigger than the denominator, that means we're going to have over 1 whole. We're going to have an improper fraction. So you think about an improper fraction, it's almost like if a person's head was way bigger than their body, that would be weird, right? Wouldn't be wrong, it just would be strange. You don't see that very often. So the same thing with improper fractions, the top of the fraction, the numerator, is bigger than the denominator. We call that improper, even though it's not wrong. It's just we don't see that. Proper fraction would be always less than 1. Improper fraction is usually greater than 1. Okay, here we have 1/9 of cider. Because what can you do with apples?
Turn them into cider, apple cider.
Apple cider. Is there anything else you like to do with apples?
Apple pie.
Apple pie, yes. What else?
Applesauce.
Applesauce is delicious. What about an apple fritter? That's so good. Do you know what that is? Oh, it's a donut. It's a special donut that has apple in it.
Oh.
Yeah, I know. I'm sorry that I told you about it. What is the difference between cider and apple juice? Well, cider is squeezed from fresh apples, and the liquid is tan and full of pulp. So sometimes my neighbors, they have these apple pressing where in the fall, when they harvest all the apples, they make a bunch of apple. Bless you.
Thank you.
Here's some apple juice. Now, which glass do you want of apple juice?
What whole?
One whole. So here you have 1/4 or 1/4, 1/2. If you double it, you get 1/2. If you had 1/4 and 1/2 together, you get 3/4. And what if you put the 1/4 and the 3/4 together? You could get 1 whole.
Oh.
Yes. Do you like to do baking? You probably use cups like this when you do baking. What do you bake? Apple pies? Cake, cookies? Maybe?
Cookies.
Mm-hmm.
Cupcakes.
Sounds good.
Cake.
Yum. Apple juice is cider that has been filtered. So the tan pulp is removed from the apple juice to make it clear. Are you thirsty? Would you like 1/4, 1/2, 3/4, or 1 whole of a glass of apple juice? You already picked the 1 whole. Here is 1/10. So, and 9/10. 1/10, 9/10. Here are 10 apples. Well, there were 10 apples. There are 9 apples, and 1 has been eaten. 1/10 is now a core. 9/10 are the whole apples. So we can say if you have 10 apples, if you ate 1 of them, you ate 1 out of 10. You ate 1/10 of all the apples. Does that make sense? You can also use fractions like that as well, without cutting the apples up. Here we have 6/10. 2/10 go into juice, 2/10 go into pie. So all together, these are all the 10 apples. The millions of tons of apples harvested every year are still picked by hand. Isn't that amazing? That means every single apple that you eat, someone else has picked it off of the tree. All picked by hand. Why do you think they would have to pick apples by hand? They can't have a machine do it.
Because.
What happens if you were to drop an apple on the ground?
Can't eat it.
Well,
it's
you
already
could.
dirty.
You could eat it, and maybe you wash it off. But what would happen is underneath the skin of the apple, it would be all bruised. So if they took a machine, probably, that's what I'm thinking. If they took a machine and they went through and tried to gather all the apples, they would just bang around and they would get all bruised. So they actually have to probably climb up on a ladder and pick the apples down, right?
Mm-hmm.
So out of every 10 apples, 6 of them are eaten fresh. So that's what they're saying. 6/10 of the apples are eaten by people out of all the millions of apples.
Wow.
And then the remaining 2 out of the 10, 2/10 of them are made into juice, and they're squeezed into cider or apple juice. And the remaining 2 out of every 10 apples is made into canned apples, like you were saying, applesauce, pie filling, jams, jellies, and dried apples and apple butter. Ooh, have you ever had apple butter before? It's like, it's basically kind of like jam. Apple pie. Yay. While you were reading this book, someone baked an apple pie. Let's eat a fraction out of it. Do you know about what fraction of the pie that one piece would be? Usually we cut things like pizza and pie into how many pieces? Can you visualize that? If I were gonna cut here, I would cut across, and then I usually cut across in half again. If I cross half again and half again, half, 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 usually, maybe draw a circle on your paper and pretend like it was a pizza or a pie, and imagine yourself cutting it into slices and see how many slices it makes sense to cut it into. You want to show us what you drew? Very nice. How many slices are there?
8.
8. So what would we call this slice of pie?
1/8.
1/8. Wonderful. Well, thanks so much for reading with me today. Anything else you want to say before we end?
Thank you.
You're so welcome. You are a great student.